Picture this. The wind screams across an endless frozen wasteland, carrying snowflakes like tiny daggers through the air. The temperature has plummeted to -40 degrees Fahrenheit. This is the Eurasian steppe, 30,000 years ago, locked in winter's merciless embrace for the next 6 months. If you stepped into this landscape today, even with your modern gear, you'd have maybe hours before the cold claimed you. Yet somehow entire families lived here. Not just survived, they thrived. Children played in this frozen world while their parents created art so sophisticated it still takes our breath away today. They had no heated homes, no insulated walls, no furnaces humming in the basement. So how did they do it? How did our ancient ancestors not only endure but flourish through the harshest winters in human history? Most of us imagine early humans huddled miserably around flickering fires at cave mouths, barely clinging to life. But that picture couldn't be more wrong. The truth is far more remarkable. These people were engineers, Arctic engineers who developed winter survival technologies so advanced they'd impress modern experts. Their secret? A revolutionary way of thinking that changed everything. When nature tried to kill them, they made nature work for them instead. Every choice they made, from selecting materials to designing heating systems, followed this brilliant principle. Instead of fighting the snow, wind, and bitter cold, they learned to turn these deadly forces into their protectors. The evidence of their genius lies scattered across the northern regions where early humans pushed the very boundaries of where life was possible during the last glacial maximum, between 15 and 30,000 years ago. At sites across this frozen landscape, scientists uncovered something extraordinary: remains of humanity's most sophisticated engineered cold weather housing from this challenging period. These weren't random shelters thrown together in desperation. These Arctic pioneers had carefully excavated circular depressions, some 8 feet deep and 12 feet across, creating the foundations for underground winter homes that would shame modern builders. The engineering behind these underground shelters reveals minds that understood principles we're only now rediscovering. By digging below the frost line, these ancient builders tapped into the Earth's own heating system. 6 to 8 feet down, soil temperatures stay remarkably stable year-round, 20 to 30 degrees warmer than the killing cold above. This wasn't luck or accident. Scientists examining tool marks and analyzing soil layers found something amazing. These depths were deliberately chosen for maximum thermal efficiency. Every foot they dug was calculated, every measurement planned. But the real breakthrough came with their development of something we now call composite insulation systems. At Dolní Věstonice, in what's now the Czech Republic, archaeologists made a discovery that changed everything we thought we knew about prehistoric technology. Dating back 26,000 years, they found winter shelters using layered insulation techniques that weren't seen again until modern times. Picture the walls of these ancient homes. Not simple barriers, but sophisticated thermal systems with multiple layers, each serving a specific purpose. The innermost layer consisted of carefully prepared animal hides, with the fur facing inward to trap warm air against the occupants' bodies like a living blanket. Outside this, a layer of dried grass and moss provided additional insulation while wicking moisture away from the interior, preventing the deadly dampness that could turn a shelter into a frozen tomb. The outermost layer used woven mats crafted from reeds and bark, creating a wind-resistant barrier that still allowed moisture to escape, preventing the condensation that could freeze and destroy everything. But if you really want to see prehistoric engineering at its peak, you need to witness the mammoth bone houses of Ukraine and Russia. At sites like Mezhyrek and Kostenki, built between 25,000 and 15,000 years ago, researchers discovered structures so sophisticated they represent some of the most advanced prehistoric architecture ever found. These weren't huts. They were engineered buildings designed specifically for extreme cold survival, and their builders were master architects working with the bones of giants. The mammoth bone houses began with foundations that would make modern contractors proud. Builders excavated perfectly circular or oval depressions, 12 to 16 feet across, sized precisely to house extended families of 8 to 12 people. They piled the excavated earth around the edges, creating berms that provided extra wind protection and thermal mass. For their framework, they chose the massive bones of woolly mammoths, creatures that had spent millions of years evolving their own cold adaptations. Mammoth skulls, some weighing over 200 pounds, became foundation blocks. Those magnificent curved tusks and long bones created dome-shaped frameworks, while hundreds of smaller bones filled gaps and provided structural support. Here's what's truly remarkable. Radiocarbon dating revealed that many of these bones came from mammoths that had been dead for years, sometimes decades. These builders weren't hunting specifically for construction materials. They were systematically collecting from natural bone yards, planning their constructions like modern contractors sourcing materials. The covering systems reveal textile technology, so advanced it seems impossible for the time period. Scientists analyzing preserved organic materials discovered that builders created composite wall systems using multiple types of animal hides. Thick mammoth hides formed the structural outer layer, sewn together with sinew thread using bone needles with precision that would impress modern seamstresses. Inside this protective shell, layers of smaller animal pelts, wolves, foxes, Arctic hares, provided additional insulation. The entire covering system anchored to the bone framework using a complex system of ties and bone toggles that allowed for adjustment and maintenance. But building these massive winter shelters was only half the challenge. Heating them required fire management techniques that would make modern heating engineers take notes. At most mammoth bone house sites, archaeologists found evidence of multiple hearth systems designed to maximize heat distribution while minimizing precious fuel consumption. Central hearths provided the primary heat source, while smaller heating stations around the perimeter created warm zones for specific activities. Food preparation here, tool making there, each area optimized for its purpose. The fuel management was equally brilliant. In these treeless steppe environments, wood was scarce or non-existent. Instead, they developed techniques for processing mammoth dung, dried grasses, and even bone as fuel. Chemical analysis shows these materials were prepared and treated to maximize burn efficiency and heat output. But perhaps the most ingenious aspect of these ancient winter homes was something modern Arctic engineers now recognize as absolutely crucial: ventilation systems. Without proper airflow, moisture from breathing and cooking creates condensation that freezes and makes shelters uninhabitable, a death trap disguised as salvation. Archaeological evidence shows these Paleolithic builders solved this problem with remarkable sophistication. At Kostenki, researchers found carefully designed airflow systems that seem almost too advanced to believe. Small openings near ground level allowed fresh air to enter, while larger openings near the top let warm, moisture-laden air escape. The positioning wasn't random. It created natural convection currents that maintained air quality while preserving precious heat. Some sites even show evidence of adjustable ventilation systems, with bone and hide flaps that could be opened or closed depending on weather conditions. These people were controlling their environment with the precision of modern HVAC systems. The social organization within these winter shelters reveals fascinating glimpses into ancient family life. These structures were designed for extended family groups, with specialized areas for different activities and age groups. Sleeping areas arranged around the central hearth, with the warmest spots reserved for the most vulnerable, infants and elderly family members who needed extra protection from the cold. Tool-making areas positioned near secondary hearths where good light and heat were available for detailed work. Every square foot planned and purposeful, like a perfectly designed modern home. Food storage presented another crucial challenge, and once again, these ancient engineers found brilliant solutions. In permafrost regions, they learned to use natural freezing as a preservation method. At many sites, archaeologists discovered underground storage chambers connected to winter shelters by short tunnels, natural refrigerators that kept meat fresh throughout the winter while remaining accessible even during the worst storms. The construction timeline for these shelters reveals planning abilities that put many modern projects to shame. Experimental archaeology suggests building a mammoth bone house required 2 to 3 weeks of intensive work by 8 to 10 adults. This meant construction had to begin well before winter weather made outdoor work impossible. Analysis of tool wear patterns and seasonal indicators shows most winter shelters were built during late summer and early autumn. Sophisticated seasonal planning that required understanding weather patterns, resource availability, and construction logistics months in advance. Let me know where you're watching from in the comments below. I love hearing from viewers around the world. And if you're enjoying this journey into our ancestors' incredible ingenuity, hit that subscribe button to join our community of history enthusiasts. Maintenance throughout the long winter months wasn't just about fixing what broke. It was proactive engineering that improved shelter performance over time. Archaeological evidence shows occupants regularly repaired and upgraded their structures as winter progressed. Broken bones were replaced, damaged hide coverings were patched, insulation materials were refreshed and optimized. This ongoing improvement process demonstrates something remarkable. These weren't desperate people just trying to survive. They were methodical engineers constantly refining their designs, making each winter more comfortable and efficient than the last. The psychological aspects of winter shelter design reveal deep understanding of human nature. Living in enclosed spaces for months could drive people to madness, something modern Arctic researchers know all too well. These ancient builders addressed this by incorporating features that provided psychological comfort and social functionality. Many winter shelters included specialized areas for artistic activities. Those famous Venus figurines found at Paleolithic sites? They were often discovered in winter shelter contexts, suggesting the long winter months became times for creative expression and cultural development. Cave art, while we associate it with caves, was also created within winter shelters using portable art objects and decorated tools. When winter finally loosened its grip, these masters of survival had specialized techniques for seasonal transition. Archaeological evidence suggests many winter shelters were deliberately dismantled at winter's end, with valuable materials carefully cached for reuse the following year. Bone frameworks were often left in place, covered with earth and stones to prevent scavenging by animals, while portable materials like hides and tools were packed for seasonal migration. The thermal efficiency of these ancient structures was nothing short of remarkable. Modern experimental reconstructions have proven that properly built mammoth bone houses could maintain interior temperatures 40 to 50 degrees warmer than the killing cold outside, using only modest fires for heating. Modern Arctic shelters, with access to industrial insulation and heating equipment, often perform no better than these Stone Age masterpieces. The techniques developed for winter survival had profound impacts on human evolution and expansion. The ability to survive harsh winters allowed early humans to colonize vast regions of northern Eurasia that would otherwise have remained uninhabitable. This expansion brought access to new resources and hunting grounds, supporting larger populations and accelerating cultural development in ways that shaped our entire species. Many innovations developed for winter shelter construction found applications throughout Paleolithic technology. Composite material techniques used in winter shelters were adapted for clothing, tool handles, and hunting equipment. Insulation principles were applied to food storage and protective clothing. The engineering mindset required for winter shelter construction likely contributed to the technological explosion of the Upper Paleolithic period. The knowledge required to build effective winter shelters was extensive and had to be transmitted across generations with perfect accuracy. Mistakes weren't just inconvenient, they were fatal. This need for precise knowledge transmission may have contributed to the development of complex teaching methods and cultural practices that ensured survival information was preserved and passed down through oral traditions that lasted millennia. Regional variations in winter shelter design reflect brilliant local adaptations to specific environmental challenges. Arctic coastal peoples developed techniques for building on permafrost, while continental steppe dwellers perfected methods for dealing with extreme wind exposure. Mountain peoples created avalanche-resistant designs, while forest edge inhabitants learned to integrate natural windbreaks into their shelter systems. Each group faced unique challenges and developed unique solutions, creating a rich tapestry of engineering knowledge that spanned continents. The abandonment of these sophisticated winter shelter technologies following the end of the ice ages represents one of the great technological losses in human history. As climates warmed and forests expanded, the desperate need for extreme cold weather shelters diminished. The hard-won knowledge was gradually lost, surviving only in a few Arctic regions where environmental conditions remained challenging enough to demand such expertise. Modern Arctic engineers studying these Paleolithic winter shelters have gained revolutionary insights into cold weather construction techniques. Military Arctic training programs now teach shelter-building methods directly derived from archaeological reconstructions of these ancient designs. Disaster relief organizations have adapted these time-tested techniques for emergency shelter construction in extreme environments around the world. The story of Paleolithic winter survival stands as ultimate testimony to human adaptability and engineering innovation. Faced with environmental conditions that should have been impossible to survive, our ancestors didn't retreat to warmer, easier climates. Instead, they developed technologies that allowed them not just to survive, but to thrive in the harshest environments Earth had to offer. When we truly consider the sophisticated thermal engineering, the complex material processing, the precise construction techniques, and the detailed environmental knowledge required to build these winter shelters, we see something extraordinary. These weren't primitive cave dwellers huddling around fires. They were accomplished Arctic engineers whose innovations laid the groundwork for all subsequent cold weather technologies. Their legacy demonstrates the fundamental human capacity to overcome seemingly impossible environmental challenges through ingenuity, cooperation, and relentless innovation. Every time we adjust our thermostats or check our home's insulation, we're relying on principles first developed by families living through Ice Age winters with nothing but stone tools and natural materials. These ancient engineers proved that human creativity and determination could triumph over nature's harshest challenges. They showed us that when the world becomes unlivable, we don't just endure. We engineer solutions that let us flourish. Their story reminds us that innovation born from necessity often surpasses anything created from comfort. These mammoth bone houses, built from the remains of extinct giants and the determination of survivors, represent human engineering at its most essential and most brilliant. As winter approaches wherever you are in the world, remember these ancient masters who turned the season of death into a time of warmth, creativity, and community. Their legacy lives on every time we create safety and comfort in the face of nature's challenges, a testament to the incredible ingenuity that lies within us all. Their innovations didn't just help them survive the Ice Age. They helped create the foundation for everything that followed, proving that sometimes the most sophisticated solutions come from the most desperate circumstances, and the most advanced engineering emerges from the most basic human need: the determination to not just survive, but to thrive, no matter what the world throws at us. Remember to drop a comment letting me know where you're watching from. I love connecting with our global community of curious minds. And if this incredible story of human ingenuity inspired you, make sure to subscribe for more amazing journeys through the untold stories of our remarkable ancestors.